Hello, Coach Holmes here, and today we'll be talking about rectangles and the different properties that we have from them. So, the biggest thing we're going to be talking about, again, is a rectangle. We all know what a rectangle is. We've heard of it before, we've seen it before. It's probably the second most common quadrilaterals that we see or use, but it's a very simple idea. It's a quadrilateral with 4 right angles. That is the most basic definition of a rectangle there is. It just has to have 4 right angles. That's it. That's all a rectangle has to be. It just has to have 4 right angles. Now, there's different properties that we actually kind of know and we just starting to know. But there's also different properties that we haven't really discussed about. And things may be a little bit different compared to a parallelogram. So these are the 5 properties that we have. Opposite sides. So what are opposite sides of rectangles? Well, opposite sides are both congruent and parallel. So if I look at this rectangle right here, LO is not only congruent, let me fix that. It's not only congruent to EV, but it's also parallel. But we also know that LE is congruent and parallel to OV. So that's the biggest thing we got to keep in mind, is that not only are they congruent, but they're also parallel to each other. Now, opposite angles. Opposite angles are what? They are congruent. And I think that's probably pretty simple and understandable, considering that a right angle is 90 degrees. So if you have 4 right angles, at least all 4 of them are 40, if all 4 are right angles, then they're all 90-degree angles. So regardless, they're going to be congruent to each other. Now, consecutive angles is a little bit different. Consecutive angles are supplementary. Now, it's kind of interesting how with rectangles so far, the properties are kind of the same thing as parallelograms, which is basically true. So even if I look at, let me do it this way. Even if I look at angle L and angle E, they add up to 180. Just like how angle O plus angle, let me do it this way. Angle L plus angle O adds up to 180 as well. And I can just simply replace this with angle V and still be supplementary to both E and O. At least angle V is still supplementary to E and O. Okay? So it still works out. But so far, it's the same thing as parallelograms. But this is the one catch with diagonals. Diagonals are both congruent and bisect. So while they are bisecting each other, what makes them different is that they're congruent. So a parallelogram, the diagonals themselves may not necessarily be congruent to each other, but for a rectangle, they are. So for example, OE is congruent to LV. That's what we're basically saying. We're not saying just E to A, we're saying that E to O is congruent to LV. For the parallelogram, that's not the case. Okay? That's not necessarily the case. Now, and then as far as four angles, Well, we know what they are. All four angles are right angles. We know that. We know that they're all right angles because we all know that they're congruent. But we want to be clear about it because we can go a little bit further with squares, where squares are all right angles and congruent sides. But this is just basically a pure definition type thing. But it's still the case. For a rectangle to have all four right angles, that's still the case. Now, moving on to this problem. So if I have rectangles PONM, or MNOP, this rectangle right here, MNOP, we want to say that MO, we basically want to solve for Y, basically. I'm sorry. We want to solve for Y. Now, MO is this whole length right here. PR is this length right here. So what I gotta do? Well, we know that this is bisected. So if I double 3y minus 5, I know that's going to be equal to 4y plus 12. Okay? I know that to be the case. So basically, I just got to distribute the 2 to get 6y minus 10 equals 4y plus 12. Next, I just got to subtract 4 from both sides, well, at least 4y. So I get 2y minus 10 equals 12. Then I add 10 to both sides, so that 2y is equal to 22. Excuse me. But what I gotta do with the 2y? Simple. Divide by 2. So y equals to 11. And that's what I actually get. Okay? Now, if I want to solve, if I'm looking for rectangles PROM, or rectangle prom, I want to be able to solve for x. Well, notice how these angles are at the same angle. At least they're a combination of the same angle, which we know rectangles to be 90 degrees. So what I can do is I can add these two up, add them up, and set it equal to 90. Because since they're on the same angle, we know that they're 90 degrees. So we just add them up. So I want to combine like terms. That gives me 13x plus 25. So then I subtract 25 from both sides. So that's 65 equals 13x. So I want to divide by 13. X equals 5. So basically what we got to remember is that with rectangles, all four angles are 90 degrees. And that's just by basically definition. We also know that opposite sides are not only congruent, but they're also parallel. Opposite angles are going to be congruent. Consecutive angles are still supplementary. So basically, rectangles kind of hold the same properties as parallelograms. Now the big catch is that yes, diagonal lines do bisect, but the diagonals themselves are congruent. And then of course, all four angles are right angles. And again, that's just a basic definition of rectangles. Thank you and have a good day.